All right, we're going to continue, and today we're going to focus on the gradient of a tangent. So let's head back to limits. In general, we want to know the slope or the gradient of a tangent line at a point x, comma, f of x. Remember, f of x is your y. So we want to find the slope between that point and another point that is a small distance away. The x-coordinate is h units from x, so we call that x plus h. The y-coordinate is going to be f of x plus h. So our slope equation is going to be this expression on the right. So we're going to be taking f of x plus h, subtracting the function, and then dividing it by h. So to get the exact slope, we see what happens as h gets smaller. In other words, let h approach 0. This is a limit. So the slope of a tangent line is using our equation from the previous slide and then take the limit as h approaches 0. So here's an example. I did write down all the steps for you. So we're going to start off by trying to find the slope of a function, and the function is a quadratic at x equaling 1.5. So I'm just going to draw a quick sketch of this function. It's a parabola. And when x is 1.5, what would be this tangent line's slope? So we're going to first have to find f of x plus h. So we're going to substitute x plus h into that function. Then we're going to have to FOIL x plus h and x plus h to get here. So we get x squared plus 2x plus h. Now we're going to use our limit formula right here. So here's our limit formula. And we're going to substitute what x plus h is in for the first piece, and then we're going to subtract the function, and then we divide it all over h. And what happens is this x squared and that x squared cancels. So we're left with 2x plus h, 2xh plus h squared over h. Now we're going to factor out the greatest common factor. So we're taking out the GCF of h, leaving us with just 2x plus h. It's not able to write here. I'm going to try this again. Now we're ready to substitute 0 in for h. That becomes 0. So there is 2x. So therefore, the slope of the tangent line for any point is 2x. So we're going to evaluate that expression for 1.5. So we're going to substitute 1.5 in, and we get 3. So the slope at x equals 1.5 is 3. So let's go back up. So the slope of this line at x equals 1.5 is 3.